Okay, good afternoon, everybody, and happy 2016. Want to welcome you all to our first webinar for the year. We're excited to have Nick Balster from Groom Energy with us, and he's going to be talking to us today about why is industrial energy management so hard. And we've got a great group of you guys signed up, so obviously this is a topic of interest for you all. So we're looking forward to what Nick has to share with us today. Just real quick before we get started, just a couple housekeeping things and just a little about UE Systems for those that might be new to us. So for over 40 years, we've been providing ultrasound test equipment to facilities and plants all throughout the globe. Obviously, one of the main applications that folks are using it for is for energy conservation, so leak detection, testing their steam traps, valves, things like that. And so, energy obviously being a big topic with everything that's going on in the world these days. So just a great tool to help you, you know, make an impact on your carbon foot impact, and save money all at the same time. So our equipment can help you do that, and our software can help you actually really show those savings to the powers that be, so they can see what good work you're doing. Of course, other applications as well: mechanical inspections, electrical testing, and so on and so forth. So if you're not familiar with all of that, we'd love for you to check out our website, where we also have tons of information and other webinars and articles about energy conservation. So hopefully a wealth of resources for you. Speaking of which, we will be recording today's webinar. So if you have to hop off early, or if you've got someone that you really want to see this presentation, then you'll definitely have that opportunity. We'll have it up on our website for you to check out later. We also invite you to ask questions throughout. We try to make these as interactive as we can, knowing though that we're all kind of spread out throughout the country. But there is a little area where you can type in questions, and I'll be monitoring those, and I'll get those questions asked to Nick, either as the presentation is going on, if it's pertinent to what he's talking about, or of course we'll have some time at the end for those questions. So definitely feel free to type those in to us. And just a reminder, we are doing this live, so just like to always kind of remind folks, if we do have any technical issues, we'll try and get things fixed and back on track as quickly as we can. With this impending blizzard coming, who knows what may happen. So anyway, just like to put that little caveat out there. So with that, I think I shall turn this screen over to Nick and let him take it away.
Great, thanks, Maureen, and thanks everyone for joining this afternoon. Maureen, my screen is coming through just fine.
It is.
Outstanding. All right, good afternoon. My name is Nick Balster. I work for a company called Groom Energy Solutions. We're based in Beverly, Massachusetts, and I've been close partners with UE for going on 8 years now. I was formerly the corporate energy manager for a company called Precision Cast Parts Corp, aerospace, industrial gas turbine, general industrial, oil and gas, metals manufacturer, forgings, fasteners, and castings, and met UE when I needed their help in my facilities to cull the opportunities, the low-hanging fruit, and have maintained that relationship over that time period. So I'm going to walk through some of my observations from the field. Hopefully, we should have plenty of time for question and answer. I'm going to walk through some slides and focus in on what makes industrial energy efficiency so difficult. So a little bit about us. This is sort of our commercial slide. We're a corporate energy services business, and we focus on manufacturing, distribution, grocery, and hospitality. Some of the more industrial-centric customers that we work with are logoed on the right-hand side. In 2015, we completed about 750 projects in 47 states and 4 countries. And my team on the industrial side did some worldwide assessments for some of our customers, partnered with utilities across the country. Very interested in making returns on investment as compelling as is possible by drawing in those utility incentives. and we've been an Inc. 5000 company. We just got named Inc. 5000 for the third consecutive year, so it's exciting times. All right, so the guts of what I want to talk about today, those of you that have been in industrial energy management, you're going to see things on this slide that are not news to you at all. But some of to sort of bucket these things, energy efficiency and energy cost savings when compared to margin made on throughput in manufacturing plants is obviously often a smaller number and perceived to be small oftentimes by senior management. When it comes to capital allocation, obviously throughput and production are what manufacturers are in business to do and to protect. And so oftentimes you see capital allocated on additional processing equipment or automation or things that are very centric to the process and not necessarily on capturing energy savings opportunities in the facility. I see an awful lot the capital requests that compete with some of the energy things that we propose in manufacturing plants and maintain or expand production, is often a capital gobbler to the detriment of energy efficiency. This is oftentimes complex stuff, as those of you that are in manufacturing plants today know. There are lots of systems. There are a lot of complexities around those systems. Anytime those systems are impacted in an unfavorable way, you got things like safety and product quality and statistical process control that can be in jeopardy. Oftentimes, the previous work that's been done has gotten a step forward, but didn't effectively scope opportunities or prioritize them. So you're left with the classic energy audit laundry list, but not a lot of detail on what to do with the laundry list. What first and what next. A lot of the opportunities, especially in the world that I came out of in the metals world, the energy is consumed by the process. So if you look at your pie chart of energy consumption, a significant portion of it is process related. And if any of you have customers that have fixed manufacturing plans from which you cannot vary, otherwise you have to get into all sorts of paperwork hassle, you know that it's difficult to tackle those process related efficiency opportunities. And a lot of customers that I've come across over the years with Groom Energy have a mentality that the technology is changing and we're going to wait for it to change so that it can achieve this type of payback or this type of efficiency, and we'll get to it. So these are the things that we compete with, and I'm lumping we there. That's facilities engineers, maintenance engineers, operations managers, general managers, et cetera. Anyone that's on the side of making progress in improving cost performance around energy. These are the kinds of things that are challenges. So I've been fortunate to, I've spent most of my time in my professional life in manufacturing facilities, both as an operator and in a corporate role, and then now as a service provider. So I've had time to reflect on how I can, what I can do and what my team can do to break down some of these paradigms and get traction in spite of these things that make this a difficult category. So I boil it down to a three-step process, and I'll dive into each through the presentation. But the three-step process begins with a service offering that we call Fast Find and Fix, followed by that type of service. We get into metering, and I'll talk more about why we meter and who the stakeholders are for having metered data. And then we get into turnkey upgrades. So historically, even in Groom Energy, and I'm sure in other service providers that you've dealt with in the field, there's a lot of focus on number three, but the lead up to number three is a little rockier. So in an effort to try and engage industrial energy efficiency opportunities differently, we take a lighter weight approach up front through fast find and fix, lower cost, rapid results, and really allow for an assessment of plant opportunities to be presented and then binned and prioritized into something that resembles a strategic energy management plan. So this type of offering is, pointedly not a big, thick consulting report that sits on a facility manager's, bookshelf and collects dust over the years. It's intended to be a very fast-moving, targeted effort inside manufacturing facilities. We use a toolkit that's got all sorts of diagnostic equipment that you'll recognize, and you'll see how UE is featured very prominently in. And then we've developed software to allow field-based measurements to be plugged into a software platform so that we don't have Excel spreadsheets running savings evaluations and incentive calculations that could be, mistakes could be made. So we've streamlined that process specifically with customers and specifically for industrial energy management. So the process looks like this. On the far right-hand side, you see a sample toolkit, and the UE 15000 in this model of the toolkit is in the center there, and then you've got infrared equipment. You've got not featured here, but you've got an amp clamp and some temperature relative humidity loggers, some data loggers. During the fast find and fix, we intend to make a big splash and take a lot of feedback from the customer in terms of what areas and what systems they want us to focus on. So it begins with a pre-visit and something that I've called an onboarding document, which is a big data collection form. We're looking for P&IDs and plant drawings and historical consumption data, et cetera, to get a very good picture of what the facility is consuming and how it's consuming prior to ever setting foot on site, so that when we do set foot on site, we can get right to work and identify those opportunities across a broad spectrum of things inside the plant. So as I mentioned, we're using software. We're using these toolkits. An interesting thing happened, and Doug Waitchen from UE Systems is on with us today. Customers started looking at what we were doing and said, "Hey, would you ever consider selling me one of these toolkits? I'd like to use them for my plants. We understand what you're doing, and we would like to, take advantage ourselves." So we said, "Yeah, absolutely." And then the next question was, "Actually, our guys don't know how to use the equipment very well. Would you be able to train us in the equipment?" And so Groom and UE partnered, and we've been delivering training together really across the world in 2015. And I look at it this way: service providers, I think, play a role in industrial energy efficiency, but there's no reason that plants can't do some of this themselves. So a lot of what we find in fast find and fix events is a bucket of deferred maintenance, compressed air leaks, steam leaks, et cetera. If I can train someone inside a manufacturing facility to make those fixes themselves and capture those savings, and also put in place a lightweight metering package so that they can see on an ongoing basis what the asset energy performance looks like, I'm going to leave that plant in a better place than I found it, which is the goal. So we are crunching all of these data and looking for real-time fixes. So I'm not interested in walking around with the classic tags and leaving a big spreadsheet or database of leak location and size of leak. I want to fix those things, and I want to do that during the event so that there's a return on investment generated from that event. And also, in starting a relationship with a customer, I'm interested in partnering with industrial manufacturers to help them improve over time. I'm not particularly interested in, fulfilling one project and then picking up and moving on. I want to be around customers. So that's the focus of the fast find and fix. and we're obviously casting an eye to other opportunities that are longer term, more significant savings and opportunities, and I'll dive into that a little bit toward the end with some case studies. Excuse me. So here is the type of stuff that we find during fast find and fix events, and certainly the air leaks will be no surprise to anyone. There are unfortunately very few facilities that I've been into that don't have some level of compressed air leak load, but we can help there if we think about a minimum submetering protocol that establishes a baseline and then allows for facilities and maintenance engineers and managers to participate in the process and check their energy performance over time. In the lower left-hand corner, this is one of my favorite examples from a fast find and fix event. We were at a facility in Northwest Illinois last February, and it was about 4 degrees Fahrenheit outside, and we stepped outside of the boiler house, and it appeared that I was helicopter dropped into a combat zone. I heard lots of popping, and it was unclear. It's unclear what was going on. Very cold, very windy, late at night, very dark. And one of our engineers focused the infrared camera on what you see in the center of that photograph, which is a 250,000 gallon fire suppression tank. The plant did not have enough pressure with the city water, and so needed to have auxiliary fire suppression. The fire suppression tank was theoretically thermostatically controlled with a steam coil through it so that it didn't freeze in Northwest Illinois in the wintertime, where it can get very, very cold. And unbeknownst to the plant, and no idea when it failed, but the steam coil failed, and we were firing live steam into a 250,000 gallon tank, making it the largest hot tub on the planet. So then when we talk about metering, we're doing a few things with metering during these events. One, we're deploying metering. So we'll talk to plants and we'll see if there are specific things that they want metered on a temporary basis typically during the event, so we can capture some data. And we'll usually ship metering equipment out to a facility in advance, so we've got a baseline and we can look at pre and post intervention type data. We'll also be sizing, CTs and steam lines and the like for discrete equipment that we're going to recommend implementing a system for. And we're then taking the data and trying to convert them into information using whatever existing systems customers have, Wonderware, what have you, just a place where the data can reside. And then we're working with operations and planning and accounting to try to get more relevant data also populated so that we can get to normalized consumption. Because in plant-to-plant comparisons, or if there's a group of facilities that are all producing the same product, and absolute comparisons don't make a ton of sense. One plant consumes 10 million kilowatt hours a year, the other consumes 15. So what? We don't really know what that means unless we're normalizing it to some production amount, a pound of throughput or a pound of material released to the floor or what have you. And what this allows for in the lower right-hand corner, this is a food manufacturing facility that we implemented some compressed air metering into. So we've got power flow and pressure metering. On the y-axis there is CFM, cubic feet per minute. And then the x-axis is time. And when we first met with these guys, they were performing at the red level and a pretty abysmal CFM per kW ratio on their compressed air system. Then what you see as you index down from, apologize to any folks that are colorblind, but the top trend is red, the next one is yellow, then green, then blue, then purple. Each of those represents a phase where we have proposed projects to improve the compressed air system performance and take them from what was a worst-in-class or near worst-in-class compressed air system performance down to a world-class level on that bottom trend. So another piece of what comes out of a fast, find, and fix, one of our deliverables is a wrap-up presentation. Typically that's to senior management and plant management. And I presented these things just to show that we cast a very wide gaze when we go into manufacturing facilities. Typically we're ranging between 15 and 30 discrete project types. They give us some options. They give the plant some options. Because we work with utilities as closely as we do, and for those of you that have been doing this stuff for a while, you know that where we want to get to is into a custom incentive or a special incentive category. And that's often done by creating packages of what are called multi-measure opportunities. So grab some steam savings and some electric savings. And the tendency nationally is that when you take that approach, you unlock higher percentage levels of utility incentives. So I'm a manufacturer at heart, and if I could give this stuff away for free and improve the state of manufacturing, I do it. But everybody needs to make a living, and my goal is to make these things as palatable to manufacturing facilities as possible from a return perspective, because I know that there's a lot of competition for capital, and I'm just trying to support manufacturing from an energy perspective, but plants are complex places. So this gives us some options. We take this a next step, and subsequently we'll create the bundles that I mentioned and propose those bundles to plants and sort of walk through the logic of why the bundles were created. We're taking into consideration machine uptime, planned preventative maintenance, any shutdown periods, production schedules, et cetera. We know that we've got to weave very carefully into and out of systems in plants because plants don't tolerate downtime very well, nor should they. So we're trying to be very thoughtful about the approach to maximize the return and be minimally invasive, and then deliver turnkey solutions. And then we get to the implementation piece, and in the implementation piece, we're finalizing all of those considerations and coming up with a battle plan that we can work with a plant and a utility. The metering plays well here. The metering provides utilities, our customers, as well as our engineers, baseline performance of the systems that we intend to do work on, as well as baked-in measurement and verification on the back end. Excuse me. Utilities in particular love it because oftentimes there are, I think the industry term is haircuts given to incentive applications, whereby they will reduce the amount of incentive because there's some tension around achieving the calculated energy savings. So we're able to overcome that and drive to smaller haircuts, if you will, because we're proposing that metering is part and parcel of project delivery, and that tends to work well in negotiations with utilities around utility incentives. So now I've got a few case studies, instances where we got in motion with facilities and the kinds of things that we could unlock as a result of following this three-step process. Atlas Global Solutions is a business that produces boxing and crating solutions for myriad different, including healthcare and high-end IT hardware, et cetera. They're located about 20 minutes from my house. I've been around these guys for 4 years. Great business. They also happen to be partnered with Pelican, the makers of the bomb-proof Pelican cases that you see traveling around airports and shipping in FedEx trucks and stuff. And they've got design engineers that customize the ballasting inside the toolkits. So toolkits started as just tools for us, and working with Atlas and with our customers, they've become really energy and reliability toolkits. For those of you that have toes in reliability or energy, I've always been fascinated that the reliability engineers seem to have less of an issue getting capital approved than the pure play energy guys do. And I think that probably has to do with the fact that reliability is very, very close to core business, and energy management is, a slightly tangent in the manufacturing business. So we ran our playbook here. We identified lots of savings. This facility happens to be a 2-year-old facility when we walked into it, and the energy savings over the span of project implementation reduced the plant's energy consumption by 55% on a 25% increase in throughput. So that was really, candidly, quite striking to me, that you had a 2-year-old facility that very much appeared to be state-of-the-art and well-constructed, but we were still able to find great savings opportunities inside that environment. This is part energy management and part infrastructure upgrade. This is a food manufacturer, a company called Pinnacle Foods in Fort Madison, Iowa. They manufacture Armour canned meats, and they had, I'm pretty sure, the oldest compressors that I had ever seen. They were once through cooled reciprocating compressors that I'm fairly certain when we demoed, we shipped them to the Smithsonian to be put on display. But this was an interesting project in that Fast Find and Fix uncovered a number of the types of deferred maintenance opportunities that we saw, but it also uncovered this one. In food manufacturing, there's a process called CIP, clean in place, and they previously were using a gas-fired heater to generate the hot water required for the CIP process. The once through cooling was sending 43 million gallons a year of water down the drain, and there were energy savings opportunities. So it was an Atlas Copco solution here, base load machine, VFD machine, and used a packaged waste heat recovery pump skid to capture the wasted heat off of the air compressors and productively use that for CIP heating. So pretty cool project. Great support from the utility there as well, and good outcomes there. So, largely in response to, from my own experience and from working with customers over the years, this is how I think about a phased approach in starting to break down the difficulty of driving industrial energy efficiency. You start with a fast find and fix, which relative to a capital project is a small investment. We are targeting a return on investment while we're on site and delivering value on those initial invested dollars. And then the next step is let's get in motion with a minimum amount of metering. We're not looking to do a full-scale, costly implementation. I'm really most interested in the data and making sure that the data and the information generated from the data are useful to utilities, to us, and to customers. But it does not need to be a full-blown, very costly solution. And then we, with our own recommendations, feedback from customer, feedback from utility, et cetera, create a strategic energy management plan that I would say typically, puts it out, call it 3 to 5 year sort of timeline to get from where you are today to where you want to and need to be to stay competitive in the future, working together, on the path to get there. So it's working for lots of our customers. It's really intended to be focused on industrial manufacturing and deliver an answer to what to do, because energy efficiency in industrial manufacturing plants is difficult. So that's all I've got. Thank you for letting me get through that. And at this point, Maureen, I'll take any questions that have come up along the way.
Okay, sure, great. Well, good information. Appreciate that. We do have a couple questions, and obviously, folks, feel free to keep tossing them in. We've got a little time here. So, one question that came in: what is a leak rate % you would expect to see in a compressed air system?
So the Department of Energy generally says 20 to 25%, and I'd say we find largely that that is in line with what we see. Industrial manufacturing is it sounds specific, but obviously looking at the people that are online right now, it breaks down into lots of different sub-segments. And I generally think that in processes where the compressed air delivery is critical to the production process, not general shop air, but instrument air. And I was just at a facility in New Jersey this week that had an instrumentation air loop. That system had very, very few compressed air leaks in it, because if the leak load goes up too much, then their robots don't function properly. Whereas in the general shop air, 85 to 110 pound air that's being delivered to pneumatic equipment, hand tools, etc. It takes more, I think, to see an impact on the production process. And oftentimes what we find is that there's a correlation between the pressure that is set for a facility and the leak load, i.e., one of the things that often happens, because it's a quick fix, is if someone is complaining that they're running low on air, the belief is if you crank the pressure up by 5 pounds, that can be overcome, and that has its own set of ills associated with it. But I think 20 to 25%, I would say, is a decent range based on our data.
All right. Let's see. They're really flying in now. What is the best way to help with the cost reduction on dust collection?
Dust collection is a great one. So there are different types of dust collectors. Obviously, you've got a standalone dust collector. Oftentimes a Torah Donaldson or something like that is connected directly to a piece of equipment. And then there are central dust collection systems. And I've seen a number of things. Let's take the standalone by itself. If the standalone dust collection unit is tied to a sandblast machine, let's say, there's overlap here into preventative maintenance, and one of the things that I've seen work well is making sure that there is a PM around nozzle checks of the sandblast equipment. There's an abrasive material that's being used. Depending on the type of nozzle that you've got for the sandblast equipment, if the orifice on that nozzle grows over time, now you're passing more compressed air through to do the same job. And the problem is it's very difficult to see because it happens gradually and over time. So the DOE would also say that every year on year, manufacturing plants get 4% less efficient. And the reason is that bearings begin to wear, orifices begin to open up, everything gets a little bit older, and unless you've got a really bulletproof preventative maintenance, predictive maintenance system in place, and you're doing replacements of older equipment, that starts to eat at you after a while. So back to dust collection. PM orifice checks are great controls that will sequence a dust collector to function when the media is being blasted, but not constantly. Oftentimes those interconnects aren't present. Checking if it's now we'll switch from a standalone to, say you've got 10 drops on a dust collection system. interlocks and controls, gated controls that allow gates to be closed when specific cells or pieces of equipment that are tied to the dust collection system aren't in use. Flip back to that business that I mentioned before, Atlas Global Solutions. They had a 150 horse fan motor on a central dust collection system that had 10 drops in a probably 25,000 square foot section of their facility, and it was running constantly. And we gated the discrete pieces of equipment and tied them into motor starters and control panels, and we're still maintaining the same face velocity and the same static pressure at the dust collector. Those things are, if you're doing anything in dust collection that is combustible, whether it's titanium or wood or some type of polymeric material, you don't want there to be a lot of residual material left in the duct, because that can present a fire hazard, and nobody wants to get hurt. So we tied all of that then into a VFD on the fan motor, and surprisingly, I guess they used their equipment less often than they believed they did. And based on their input, we said that they were going to save 60% of that fan motor energy consumption. I was just with Frank, the general manager at Atlas, last week, and we've got meters on the equipment, and he showed me the trend, and they're actually saving 88%. So that isn't necessarily a incredibly job well done Groom Energy. That is the process required far less than the customer actually believed it did, and we've got the data. We've got the data to prove it, which is great. So, those are some things to look for in dust collection. Also, looking at if you're pulsing pneumatically, checking that pneumatic system, and oftentimes they will be set to a timer-based process. So you'll walk back into the back part of the plant or wherever the dust collection system is, and you'll hear the constant pulsing, but there's nobody at a workstation. So that's just a pure compressed air loss, and as we all know, compressed air is expensive. So dust collection is a great category for energy savings, and increasingly I see lighting anymore for utilities where it has been the silver bullet over time, and they could count on it, and they could plan for it. A lot of plants have done lighting already, so the utilities are looking for for plants and for service providers to find other opportunities. So dust collection, in my experience, typically comes at really pretty great incentive percentages.
All right. Well, it's interesting you bring up the lighting, because that kind of ties into, I had two separate questions come in that are a little bit tied to each other. One person wondering what a reasonable payback would be to switching to LED lighting. And then to kind of tie into that question, another person says they've already done that kind of upgrade with the LED lights. So wondering if there's any other electrical savings that they might look into other than aside from lighting and the motion detection lighting. I can't speak.
No problem. So to the first question, I would say a range to think about for paybacks, and this is obviously completely dependent on when you look up in the high bay or the mid bay of your facility, what do you see? If you see something round and it's metal halide, high pressure sodium, that's going to be a stunning payback, especially if it's intelligent LEDs that are that have controls integrated into the fixtures. That could be an 18-month payback or less, because utility incentives are pretty varied. If you look up and you see linear fluorescence, you're probably looking at between a 2 and a 3 year payback, probably closer to 2. One of the things that is typical of manufacturing facilities is whether or not the facility actually runs 24/7. The lights often run 24/7, and there's another requirement of ours is that we want to get data loggers in there to see what the run hours on fixtures actually is, because there's, it helps with utility conversations, and there's an awful lot of manufacturers that I talk to that say, oh yeah, the plant runs 24/7, and whether you look at the interval data from the plants, or you put some light loggers in place, and I used to do it all the time. I've been in plants. I was in plants for 10 years before I jumped out into a service provider role. I used to tell everybody we ran 24/7, and you go in on third shift on a Friday night, and there are 3 people in a 1 million square foot plant. That's not really running 24/7. So there's a lot of opportunity there. The technology anymore around LED, the prices have come down so dramatically, and the efficacy is improved so drastically that the number of lumens that you can get per watt of fixture is stunning compared to where it was even 2 years ago. So that's LED replacement. Those are my thoughts, and those looking for opportunities beyond LED lighting. We typically focus on what I call central plant utilities. What utilities are you running inside the shop that are feeding your production equipment? So I don't go into a whole lot of manufacturing facilities that don't have a compressed air system. Oftentimes there are discrete portions of manufacturing plants that have some amount of climate control, whether that's for creature comfort or for product quality impacts. 2015 we saw an awful lot of plants that were interested in talking about HVAC because product quality benefit was substantial. A lot of scrap and rework associated with temperature and relative humidity swings. A lot of plants run big steam systems, chilled water systems. Anything that you see that's connected to the switch gears and the sub panels beyond lighting, odds are there's something there to be investigated. Whether or not there's a substantial savings associated with it, requires some engineering investigation. But if whoever asked that question, if they want to do a deeper dive on it with some more details on the plant, happy to do it. I've got my contact info up. You can feel free to email me, and I'll give you a call. We can talk about it more.
All right, and you've mentioned a couple times about the utility incentives. So someone's wondering, how do they find out what incentives are available in their facility? What's the best way to do that?
So there's a great website. I know I saw some international participants, but in the U.S. There's a great website, and I'll read it off now, but it's a great place to start. It's called DesireUSA.org, DSIREUSA.org, and it's run by North Carolina State, I believe. There's a technical energy organization, and it is an aggregated look at all of the U.S. based on a scrub of utility websites and the latest information on their incentive programs. Great place to start. Doesn't always have the most accurate information because it gets updated at some frequency, but not. So it misses some things that are just time sensitive. But great place to start. The other thing is every plant is paying a utility to get the electrons and the cubic feet of gas to the plants. So every month you're getting bills, and there's a phone number listed there. And I would encourage all of you to reach out to your utility reps, and I would say put them on the spot. They are serving you. You have the opportunities. They want the savings. They're mandated typically by the public utilities commissions and public service commissions to set money aside to help their customer base become more efficient. You look at the investment by a utility in added infrastructure versus energy efficiency, and it's a great value proposition for the utilities. So put them on the spot. Tell them that there's an initiative. They want to understand what contribution they can count on from the utility, and if all that fails, shoot me an email and I can help, because we're partnered with utilities across the country. We do lots and lots of projects, and the one thing I would say is that DesireUSA.org will take you to a utility website. A utility website will have some published information, typically about prescriptive programs. You get $50 for this fixture, and you get $50 per horsepower for this drive. Every utility incentive is a negotiation, and you as customers, as end users, and particularly industrial manufacturers, because there are large loads there, you're important customers, and every one of those situations is a negotiation.
Well, that's good advice. And someone cautioned that we make sure they're going to the right site and not spelling out Desire. So it was DSIRE.
Yeah, that's why I spelled it out. There's no E. It's just D and then S and then
right.
II. Yeah.
We could get some people in trouble. So what I'll do too is, Nick, I'll get that website from you, and I'll get an email out to everybody that's on today with that link and some other information too that we can share on the topic. So hopefully that'll help. Okay, well,
I know people have a sense of humor on a Thursday afternoon.
Yeah, they seem to, so that's good. Okay, well, let's do just one more, and then there's a few folks that have asked questions that I think, Nick, might just be better for me to get them to you because they're a little more personal to their facilities, and you guys can have a conversation offline. So we'll do one more. I think this is a good one to kind of end on since we are kind of all about reliability and all that good stuff. So just to kind of wrap it up, what are kind of your final thoughts on how to link, better energy management to the overall picture of reliability and safety and these things that we really want to be, focused on and doing a really good job at?
Yeah, that's a great question. So the world that I grew up in aerospace manufacturing largely taught me that if something is important, if something needs to be continuously improved and visible and understood by people making decisions in the businesses, you got to bring the data. There's all sorts of phrases that I learned. In God we trust, all others bring data, right? And we've all heard this kind of stuff before. But I think it's really true here. In order to, I spend a lot of time with facilities managers who are disgruntled when we start talking about energy efficiency, because they say, Nick, I've submitted projects in the past and I've never been able to get them approved. So I say, well, let's take a look. Let's look at what your capital requests look like. And part of what I do oftentimes with my customers is write a business justification for them, just a draft, just some thoughts, and downloading our proposal into their capital request template. But I think more success can be had in really presenting the data and the information effectively, and just like any other investment in a business, focusing time and attention on the full business justification. So if there are reliability improvement potentials, let's figure out how to quantify that. Qualification is great. Quantification rules. Same for safety. It's great to say we need to go do X, Y, and Z, and people will be safer. How many people were hurt last year near that? How did that impact your OSHA statistics? How might we envision that this type of intervention could improve those things? With improved safety performance, insurers are interested in that. Definitely employees are interested in that. And there's a safety manager somewhere that is similarly very interested in that. So it's a great question because, I'm an energy guy, and a lot of what we do in manufacturing plants does have an impact and improves performance around reliability and safety. It's my job to help roll up the sleeves and dig in and figure out what those impacts are going to be so that we can be looking at the improved performance across those categories some ways down the road rather than talking about them and missing those opportunities. So I hope that answers the question. If not, shoot me an email. Happy to brood on it more with whoever would like to participate.
All right, great. Well, that was really, really good information. Obviously sparked a lot of questions and conversations, so that's always a good sign. And if you like what you heard from Nick and you want to hear more about it and talk with him and get even more info from him, he's actually going to be one of our featured speakers at our upcoming Reliable Asset World Conference taking place in May. I've got the dates on an upcoming slide here in a second, but just wanted to point that out. So we're looking forward to having Nick down there and talking, energy, obviously. So that's going to be really good. So just to kind of close up here, so I mentioned at the beginning of the webinar, our website, uesystems.com, really good place. We try and pull as much information from smart people like Nick that we're happy to be friends with, that we can kind of give you kind of a one-stop shop for everything you might need to know about whatever topic you're looking for. So definitely take a look at our website. All these webinar recordings that we've done are up there, articles, white papers, you name it. We've hopefully got it, and if we don't, let us know, and we'll see what we can do to help you out. We also, love to stay connected with you all. So we've got 2 different LinkedIn groups. Great place to carry on some of these conversations that you guys have started with the questions you've asked, and bounce, feedback off one another. Always a good way to learn from your peers and keep the conversations going. So LinkedIn is great for that. We're also on Twitter, so you can check us out there. And as I mentioned, I'd show the dates here for our upcoming conferences. So Ultrasound World and Reliable Asset World co-located together May 10th through the 13th in beautiful Clearwater Beach, Florida, which in the next 24 hours or so, I'm definitely going to be wishing I was there as the snow starts pounding, but May will be here before we know it. So take a look at our website and see if those are events you might be able to attend. And coming up, we started this last year and we're going to do it again this year. We're going to focus our efforts in February, or Lubruary as we like to call it. So it's going to be everything and anything lubrication related. So our first webinar, we're going to have 3 throughout the month, but our first one's going to be February 3rd, and it's 10 ways a lube tech can improve reliability. So for those of you on here that aren't just the energy guys at your plant, definitely take a look at our upcoming Lubruary events. So with that, I'll leave our contact info up, and this is how you can get in touch with us. And hopefully we'll see you all back here for a webinar in February or Lubruary. And Nick, thanks again. Really appreciate it. And for those that are in the